Alright, here we go. 15.3, page 405. So, freshwater pollution and its control. So, the first thing I write down here, the first one we're going to talk about is aquatic ecosystems are hurt in multiple ways, which shouldn't be a surprise as we've been talking about humans impacting everything. So, we can make dams, we can do a whole bunch of river diversion, so basically taking a part of a river to, go over and irrigate a certain farmland or fill up a different lake somewhere else that they can use for fresh water for drinking water for a city or something like that. A whole bunch of different ways. There's also that we just straight up use too much water. Like look at the freshwater lakes around the United States, they are dropping dramatically because we're just simply using too much water. We are also polluting the water. So I talked real briefly about like the Mississippi River. That place is disgusting. It's really brown because of all the pollution from it. All the runoff from different farms and cities across basically all the states that the Mississippi River watershed entails, which, by the way, is more than half of the country. All of those pollutants and everything is going down into that river. So over half of the world's rivers are badly polluted. And even here in the United States, they say 55% or a little bit more are polluted. Now, one of the ways that they're kind of tackling this issue is more of a prevention problem. And it says it right underneath here, which I kind of like this thing. Pollution problems embrace the preventative strategies rather than the end of pipe treatment and cleanup. It's like that phrase, end of pipe. So basically, they're looking to more prevent the pollution rather than putting money and a ton of stuff towards just simply cleaning everything up. Another thing I wrote on here, the next tab, or next sticky note, excuse me, I'll zoom in a little bit, is the point source versus non-point source. And we've talked about this a couple times, so this should be pretty straightforward. The point source is a particular factory, a particular sewage pipe, a particular oil spill that occurs, whereas the non-point source is the farms and the cities and the runoff, like in the Mississippi River watershed. So the Mississippi River is polluted. Where does it come from? Well, non-point, because everything just kind of flows down into it. Toxic chemicals flow into it, both synthetics and the heavy metals flow into it, like we talked about, they become soluble because of the acid rain. Then pathogens also get in there, which spread disease really quickly. And that becomes an issue because if there's let's say that there's some sort of pathogen up in Montana, well, eastern Montana is part of the Mississippi River watershed. So that pathogen can come down to, like Missouri and infect the organisms that are living in Missouri. And so diseases can spread really fast because of that easy transmission through it all. All right, moving to 406. This diagram here is kind of a good diagram of just overall what I've been talking about. Like if you think of this as the Mississippi River, all these different things are basically inputting basic terrible pollutants into it. We got acid drainage, we got oil spills, eroded soil, and so on, so on, so on. Basically everything is flowing down into that river, which starts basically going towards the ocean. Now, the nutrient pollution, which basically that's the reason we have the Gulf of Mexico dead zone. That nutrient pollution, you put a whole bunch of nutrients, such as nitrogen from fertilizer, that's going to create a dead zone. So it also hurts the industry and the workers because there used to be a fishing industry in the Mississippi River, but now there's basically not. There's a little bit, but there's not as much as there used to be. And this is due mainly to nutrient runoff, like I was talking about, like with farms and animal feedlots, just running down into the Mississippi River. All right, so these two pictures here on figure 1524. So there's a thing called a ligotrophic water body. So basically, what this is there's not very much nutrients in the water, so there's not much life. But you can look at it; it's very pretty. Flip to the other side, it's eutrophic. So eutrophication, basically a whole bunch of nutrients get in there. It creates these algal blooms. And that's obviously a bad thing. And that's what I wrote about here in the sticky note there on the bottom, is a biodegradable waste. So like human waste, animal manure, yard waste, etc., things like that. So like basically like legit from cities, or think of more rural areas or poorer nations, just straight runoff from that city. The animal manure from the feedlots, the yard waste from all like the, people cutting their grass that just washes down the sewer, things like that. The bacteria feed on those things, and then they lower the oxygen levels. Then, when like the algae die, decomposition also eats up the oxygen, which basically creates the dead zone. Now the wastewater, that's water that can be a source of biodegradable waste. So the wastewater typically can contain some of this stuff as well. Now they also talk about sediment. And I'm talking about the Mississippi River, but the Puyallup River is the same thing around here. The sediment, basically, it's just really kind of cloudy or it's brown. It's, if you go scuba diving, the visibility underwater is just nothing. There's also a thing called thermal pollution. So warmer water holds less oxygen, and that becomes an issue for water treatment plants because typically they will spit out warm water after everything has been done. So warmer water holds less oxygen. Less oxygen means less life in the water column. All right, so now moving on to 408. So here I talk about groundwater pollution is hard to detect and regulate. So if stuff's just kind of like running along the street per se and just kind of infiltrating the soil, it's hard to figure out where it all came from. So toxins seep into aquifers. Remember, the aquifers is like where the wells are going to. So that way that town can have drinking water, or it can have quality irrigation and stuff like that. So if you contaminate an aquifer, you're really, really going to be in trouble with drinking water for cities. Like underneath the Midwest, thing called the Ogaga, or I can't remember how to say it, the Big River Aquifer, or Big Aquifer underneath the ground, which is why the Keystone Pipeline goes around it. Because if we screw up that aquifer, we're screwing up the drinking water for a lot of different states and cities over there. All right, moving to 409. So we treat not only our drinking water, but also our wastewater, which is good. Like I was talking about, they're trying to get that preventative stuff going. Septic systems are also very common. So like my parents are out in Gig Harbor, they're on a septic system rather than piped into city water. So there's the primary treatment, that's the physical removal of contaminants. Like sediment's heavy, so sediment sinks, so you can pull it out. Then there's also the secondary treatment, which is the bacteria degrade the organic pollutants. And in the septic system, this happens a ton. Like they talk about people needing to go in there, and basically they need to have their septic system worked on. That's basically what they're doing. There's potentially, obviously, they got to dig the whole thing up and all that. But a lot of the things, they basically kind of got to get the right bacteria working again, so that way that septic system works well. Now this picture, or this page here, 410 and 411, I don't have any sticky notes on it because it's got a really good diagram to kind of understand how this whole system works. So you can see there's basically kind of 5 different steps in treatment of wastewater or raw sewage. Then you can see on the right-hand side, there's some extra steps as well. Now, in the end, it can generate electricity and gives biosolids for cropland, but this is a lot of infrastructure and cost going into this. So that's why they're trying to do the preventative stuff rather than the end of pipe things. So you can see you got screens, get the solid objects out. Like I was talking about, solid object removal, basically goes to the landfill. Then you got the primary clarifier, you got the aeration basin, and so on. Now this effluent, or basically like the quote unquote good water, this is the warm water I'm talking about. That basically gets dumped in, but it holds less oxygen, so potentially that's going to make it so there's going to be less life in the area that the water gets dumped into. All right, leave some questions. We got stuff to talk about.